On December 7, 2022, the Keystone pipeline had a spill that was more massive than all the spills in the pipeline's history combined. The Keystone pipeline is a 3-foot diameter artery of chemical energy that pumps around 800,000 gallons of Canadian crude down the center of the U.S. every day. The recent spill occurred near the Kansas-Nebraska border, 14 miles south of the Steel City pumping station. The cause for the most recent spill in Kansas has yet to be determined, but the ruptured pipeline released 588,000 gallons of Canadian tar sands crude onto rolling Kansas farmland and into a creek within the Little Blue River watershed. It all started on a cold December night. 9 o'clock rolls by and at 9:01, a volume imbalance alarm goes off. This lets an operator know there is an unexpected drop in the incoming volume of crude. Could be a pump on the fritz. Minor alarms like this are not uncommon in the control room. 6 minutes later, there is an emergency trip line alarm, which means that the pressure in the line with no pumping is dropping. This is a much more serious alarm. Within 2 minutes, the pipeline is shut down and emergency valves are closed. TC Energy personnel are dispatched into the night to locate the potential spill. The TC crews could literally smell the leak on the highway, and they tracked it down to mile 14 of what is called the Cushing Extension, just north of U.S. Highway 36. There was no one to witness the spill, but past experience and the spray pattern evident in this recent spill tells us there was a massive geyser of crude that probably careened several stories into the sky before covering the landscape and flowing into the nearby Mill Creek. The initial estimates are that 14,000 barrels, or 588,000 gallons of crude escaped the pipe. Some of this is from the explosive release that lasted 7 minutes between the initial volume drop alarm and the emergency valves closing, but much of the spill volume comes from the draining of the pipe between the emergency valves. By looking at the elevation along the pipeline's path north and south of the spill site, we can see that at least 11.5 miles of pipe could have potentially drained out. Multiply the area of a 36-inch pipe by 11.5 miles, and we get a volume of over 3 million gallons. Luckily, not all of this oil seems to have escaped. If an oil pipeline breaks in the bottom of a valley, there is enough hydraulic head above the opening to force out a majority of the pipe volume within the valley. Cleanup operations began with personnel, booms, and vacuum trucks being deployed by TC Energy. They ultimately reported the leak to the federal hotline for oil spills at about 12:30 a.m. on December 8th. By the morning, there were officials from the EPA and state agencies on the scene. County road crews spent the first few days prepping roads for heavy trucks and machinery. Within a week, there were hundreds of personnel from TC Energy, the EPA, and the Kansas Department of Health and Environment. Under unified command, the EPA and TC Energy decided to construct an underflow dam about 4 miles downstream of the spill site. Underflow dams take advantage of oil's buoyancy to allow uncontaminated water to flow underneath an oil spill. Using this as a last line of defense, the crews used booms, skimmers, boats, hoses, and vacuum trucks to push back the advancing oil slick. According to the EPA, on December the 15th, there was oil 10 inches thick covering the creek from bank to bank for 1.5 miles. By January 25th, the oil was about 1 inch thick and covered Mill Creek, bank to bank for 500 feet. Contaminated water and oil is loaded into specialized reactors that separate the oil so that the water can then be treated and discharged back into Mill Creek. Contaminated soil is loaded into dumpsters and was being stored on site until the permits for disposal at a nearby landfill were secured. Meanwhile, heavy equipment removed the damaged section of the pipeline as quickly as possible in order to repair it and restart pumping operations. By law, the damaged portion of the pipeline has to be cut out and submitted for inspection to the Pipeline and Hazardous Materials Safety Administration. After 3 weeks, the pipeline was fixed and TC Energy was given permission to resume pumping operations. The crude oil in this case is dilbit, short for diluted bitumen. This is a notoriously difficult type of crude to clean off of surfaces, and it has an unusual weathering process that causes it to gradually sink. The dilution of bitumen is done with organic solvents such as benzene and toluene. Diluting bitumen makes it possible for this sticky, tar-like substance to be moved through a pipeline. Organic solvents are part of the oil spill initially, but once in the open they volatilize and drift into neighboring areas. As solvents leave the bitumen, it loses buoyancy and sinks. This complicates the cleanup process immensely and leads us to two questions: how much organic solvent was washed away downstream, and will there be residual bitumen in the sediment? Officials from state agencies reported they could detect the solvents downstream of the underflow dam, leading the EPA and TC Energy to devise a plan to divert the flow of Mill Creek. Using above-ground pipes and powerful pumps, the flow of Mill Creek was diverted just upstream of the oil spill to a point just downstream of the underflow dam. After this diversion was in place, there was a steady decline in the levels of contamination detected downstream of the underflow dam. This proved to be an effective measure in limiting the spread of contaminants and made the remaining cleanup much easier without having to deal with the full flow of water. There is still concern about the initial release of organic solvents and the sinking bitumen contaminating the Little Blue River watershed. In early January, the EPA and TC Energy entered into an agreement that the company would pay for the cost of cleanup and allow the EPA to direct all cleanup operations. The majority of expenses incurred by the wildlife and environmental agencies are being documented for reimbursement. Still, there are some expenses relating to the spill that will not be reimbursed and ultimately paid for with federal tax dollars. On the other hand, some local residents of Washington County are appreciative of the tax revenue that is generated by the pipeline. This past year, the two largest taxpayers in the county of Washington were the Keystone pipeline at $1.9 million and a natural gas pipeline at $670,000. This money goes towards improving schools and municipal services. The Keystone pipeline affects the lives of millions. The impact that it has is a complicated mixture of good and bad. This is the largest oil spill in the history of the Keystone pipeline and the largest inland oil spill in the U.S. in over a decade. Many believe that the Keystone pipeline construction was rushed and corners were cut in the cost of materials. Will these failures in the pipeline become more and more frequent as it ages? The risk-reward analysis becomes more complex when the majority of finished product from Texas refineries is being exported and the company makes a multi-billion-dollar profit each year. What happens when the economic viability of processing tar sands decreases and profits become thin? The process of mining tar sands is highly destructive to terrestrial habitats in Canada while also being one of the least efficient in terms of energy and carbon. Is the societal good of this industry worth the cost? Can we expect a slowly failing corporation to adequately take care of aging infrastructure that poses a large environmental risk? This has played out in history before in dismal and damaging ways, usually leaving the public to deal with legacy contamination from once booming industries. Subscribe to hear more on polluted properties.